Here is a Wurth 3/8 inch drive impact driver. I think it's an impact driver. It's big enough in the end there to have hammer action, so I'm going to say that. Model number, I haven't looked it up. Doesn't work. Let's take it apart. She's pretty dirty inside. The PCB there is kind of coated in some kind of greasy, oily mess. I scrape that off. Still a bit moist in there. I'm going to have to give it a thorough clean before we can really go any further. What appears to be a big metal heatsink at the back there, I'm guessing it has maybe either some MOSFETs under it, or there's actually some MOSFETs under these wires under the side. Let's pull this whole shebang out of the case. Does it come out of the case as one unit? Yes, it does. Making careful note what way around the forward reverse switch sits, so we can deal with that later. There's a little rotational element on top of the trigger switch that tells it to go forward or reverse. Could just be the switch that's bad. With that out, you can see how disgusting that is on top there. Let's desolder the motor. It's just a standard brushed DC motor. Once we've desoldered that, we could apply bench supply to it and see if the motor works. Rule that out. Going to put a minus beside the black wire so I know what way around it goes. This is the largest tip I have with the new station, so let's see what it goes like. It's quite a large metal tab there on the motor. May need to add a little bit of solder to that to help it. And see if I can get the heat into it. May have got it now. There we go. Worked a lot better when I cranked the temperature up to 370. I had it around 340 just to see if it could work with that, but no, I got there in the end with 370. Peppermint tea, good for grumbling guts. Now I'm going to wind the bench supply down to a bit lower. This is going to be 12 volt max, so let's clip onto here and our negative, and let's see if it'll spin. And I don't know how much current she's going to take. Let's wind it right up to full blast. Ooh, that's not happy. Aha, that's not happy at all. She just pulls a lot of current and does nothing. In fact, it's current limiting at 3 amps. Surely this thing doesn't need more than 3 amps. Maybe the brushes are gone. Maybe it is just a motor fault. If we have a look at the motor winding resistance there, it's dead short. 0.3 ohms. That should not be that low, unfortunately, I don't think. Okay, if I hook it up to my other more grunty power supply, it does run. And it's pulling about 5 amps. So clearly it's a very high torque motor where the windings appear to be 0 ohms, but they're not really. They're just such a low resistance. With the motor being determined to be good, at least for now, we can turn our attention to the control board. I think we see if we can test whether the trigger switch is working as it should. We have our positive from the battery here and our negative. Negative going to the PCB, where I'd imagine the MOSFETs are switching the negative side, and then we have the positive going to the switch, and it looks like that also goes to the PCB. And then we have a blue wire and some kind of switch on the top with a red and black going to the motor. Oh, yeah, okay, let's see if we get a connection from one side to the other, from battery through to somewhere. Make sure the battery is passing through. It does. As soon as we push it, it connects pink through to pink, positive straight through to the board, or negative's already going straight to the board. Then we have the directional switch, which is gonna, I reckon that could be passing blue out to the blue wire versus one of the motor wires. Oh, look at that. So blue wire goes through to the black motor wire. Actually, blue wire goes through to both. We can't do that. The motor output shorted. The motor output wires are shorted together. That can't be possible unless it's a trigger-based thing. Maybe they stall the motors sometimes with a trigger. They put a short across the windings to stop it. Let's push the trigger while we're checking that. If I can get 10 fingers holding that. No. So with the trigger in, it's still shorted together. So now I'm starting to think the motor drive MOSFET could be shorted. Probably easier to unsolder these fat wires from the PCB, just because they're all bent around these large tabs, twisted, so it makes it hard to, like, you know, bend them out, unsolder them. It's just kind of annoying, like I had to with the motor. But these are so short, they're just going to pull straight through. So I will remove them, and probably the skinny wire for the little red and white one up here for the battery temperature sense. In case I forget, pink, blue, black. And there's our MOSFETs. Too little. I don't know what type they are yet. If we scrape off the conformal coating a bit, we could take a measurement on the pins there. And we'll do a diode mode test across there. Drain and source, and that appears to be shorted. And the other one is not shorted. So we have one shorted MOSFET at least. Let's let me zoom in and find out what number is on that one. So the number appears to be, we've got 5302. It is an international rectifier brand. C820P LY2N. Let me look that up. So it comes up as an Infineon IRFH5302P BF. I'm pretty sure the PBF means lead free. There you go. What's it rated at? 30 volts and 175 amp peak. Well, oops, I read the data sheet wrong. Here we go. 32 amps at TA is T ambient, I think. TA of 25 degrees C is 32 amps continuous drain current, and at TC bottom 700 amps pulsed drain current. So what does this say? 32. I do have another one which is 35 amps continuous with a pulse of 400, and at TC 25 is 100 amps. So a little bit down overall, but still a similar continuous 35 amps. I'm going to stick that in. Let's first give this a darn good scrubbing. Got the old CRC contact cleaner. Should do the biz, I suppose. A bit of pressure behind it. We've got to hose it off. A little bit of a squirt, let it soak in a bit, get it all over your fingers. And then we'll go in with the alcohol. Now if you put the old the old wand out, it actually slows it down a bit. It's very fast evaporating fluid though, not much to worry about there. Pop that aside, get rid of that. I'm tempted to take this metal plate off and see if there's anything under it. I'm pretty sure there's not. It's going to just be heat sinking through the vias on the PCB. Again, there's a bit of a silicon thermal transfer pad underneath that. So that's all that is. Gently, oh no, there we go. It does just fall off pretty much. Oh, there's a bit of white thermal paste under there as well. It was kind of bonded by a little bit of this conformal coating as well. Diode mode, do we have a short? Look at that. And it looks like the gate isn't too happy either. I'll cross our fingers that we haven't blown up the gate drive. If it's driven directly off that microcontroller, that could be game over. Let's get some fresh solder on that there. Cool, can I just soak up a little bit of that? Nah. Pop a little bit more on there. It will squeeze out the difference when we pop it on. Here's our new one. Oh, where are we at? I'm surprised I had one of these in stock. And in this situation, like in business where you, well not in business, but when you're fixing stuff, you need a good supply of parts. You never know what to get. I suppose you could just go through and order, like, you know, 10 of everything. All the common transistors and MOSFETs and, when I say common, you know, just get a bunch that could be substituted into most things. Sure, there'll be some precision parts out there, but you'd probably get away with, like this. And probably get away with putting one of these in. There we go, let that harden, push down, squeeze out the excess, dab up what overflowed. We're looking pretty good. Okay, let's test just quickly. Might be our gate there, that's our gate there. And we've just turned it on, so we'll short that out, and we are good to go. 0.4 diode body drop, and the thing turned on when I put the probe on the gate. So wonderful. We can get rid of this old solder in here, and I think we're ready to give it a test. Let's see, do we have a short on our motor output wires? Let's check our resistance on there. Okay, it was blue to thingy, what's it? Do we have any? No, nothing there, nothing there. Okay, no, we could be alright. Pop these wires back in. I've just cleaned the holes out. Oh, before I do that, you're yelling at me going, you forgot the heatsink. Yes, I did forget the heatsink, which I can't put the wires back in until I put this on, otherwise it'll won't be able to get the screws in. It's gonna squish out everywhere anyway. I think it was something like this. I'm just going to put a little bit of flux there, because when I dab the iron on, I get some solder down in the holes without having to have 5 hands and hold the solder and point it in there and so forth. I think it's going to be easier to push through the hole once I get the hole nice and hot and melt the wire with it. There it goes. Alright, that'll do for a test. I actually don't have a battery, but that doesn't matter. I can run the bench supply into it. Bench supply is hooked up. I guess we will see if this thing spins. Oh, we've got a light. And I believe that light comes on when you pull the trigger. Maybe it comes on when you insert the battery initially. Yep, there it just went out. So let's pull the trigger, see what happens. Oh. Okay, so we've got a dancing lights there. That must mean there's a problem. Could mean it thinks the battery temperature's not good because, well, there's nothing there. I wonder what it should have across that. Let's see if I can find a way to simulate the battery temperature. Let's put a 4.3 k ohm resistor across the temp sense wires just to simulate something closer to room temperature of what a rough NTC thermistor might exhibit. We will reattach battery. We will get our light on. Let's pull the trigger. Oh, that didn't work. I have obtained the proper battery, and yes, it's a little different on the temp pin than I thought it might be. However, still doesn't work, but we no longer have the dancing lights. What we have, and if I pull the trigger, you may hear it, but you can hear current going through the motor. It is speed controlled, so it's I guess it's PWM. You can hear the oscillations, and then it stops and flashes the battery light like this. There you go. And then it'll do that for a few seconds. And the battery is fully charged. Now you may see a slight rotation of the motor down in the back here. Nothing happens. I'll do it once more. If I pull it a little bit harder, it starts to rotate and then it goes off. Now, I think this is possibly coming into an overcurrent situation. I mean, the motor is spinning freely. I would not have thought that there was a problem with the motor. We did get a really low resistance on the windings, but you'd expect that for a high torque motor. And wonder where the current sense resistor is, because we do have, it's probably that big one. There's a real big one just down in there. I might see if I can't pull the front end of it. I think it's held together by some locking pins that slide down through the body of it, because they were sliding out before. You can push out those pins there. Yeah, and that slides out and flicks off because my, there we go, round pins on a tweezers. We want to remember which side of the motor went in, just in case. So put a mark on there. And will that slide off? There we go. Planetary gear sets and all. There's some grease in there, which is probably due to be replaced. And we have the end of the motor. We have planetary gears. Let me get a paper towel to put them on. So that leaves us with the end of the motor. And that plastic piece is, there's a metal plate there. Does that come off? Metal plate there. And a couple of screws holding that end cap there. Okay, let's pull the trigger. and it dies. Doesn't even try to turn. If I give it a flick first. Ah. Oh. No, a little bit of smoke there. Where did that come from? It did, if I was turning it, and in just pulsing that to make it run, the heatsink is stinking hot. I just had another thought. If it is a shorting of the MOSFETs, it will do the same thing with the motor disconnected when I pull the trigger. So let's see what happens. We just won't hear any oscillations, but it'll probably do the same thing. No, I can hear an oscillation. Listen. Yeah, it does exactly the same thing with no motor. It's got to be shorting the two MOSFETs together rapidly, hence the buzzing noise, as some sort of PWM failure. On closer inspection, we can see that, so our B plus comes in here, the top left. That's always going to be B plus. As soon as you pull the trigger, it passes B plus down through to here. So here's our MOSFET, which it is now shorted. That's probably where the smoke came from earlier. I have to put another one on there. Then this is a N channel, this one's a P channel. We've got our negative battery here, and it comes through a current sense resistor and down into this MOSFET. Both MOSFETs are connected to the blue wire, which goes to our bottom of our trigger there. Now the motor output wires are up the top here, the pink and the black one, and they are, this rotating switch does switch between them, I believe. Yeah, it's right on the top there. So let's remove that MOSFET, and for now I'm just going to leave the heatsink on the other side. Can't be bothered taking that off and messing around with the white paste all over again. So we will remove the MOSFET, see if the short goes away, try and trace through where that blue wire goes to and from. Now if we check on the output of our motor connections, so our motor connections are no longer shorted, so that was the MOSFET to blame. If we go from the blue wire to the so we have the blue wire down there, and go to the, can't get it all on screen, switched. Okay, so in that position the blue wire is switched through to the black motor wire, and then if I switch that over, the blue wire is the positive. Blue wire to negative, motor negative, and B plus to motor positive. So in that position it should be driving or oscillating. It should be pulse width modulating this MOSFET to pass the negative through. It's probably doing them both at the same time, but depending on what the switch is depends on the direction of the motor. Now if we switch that back the other way, we should have blue to positive, yeah, blue to motor positive, and motor negative to B plus. What an interesting switch arrangement. So that will be passing up through the body of the trigger from the bottom there, B plus through to, depending on that switch, one or the other side, whereby it then pulse width modulates. If the system is completely unaware of which, and I think it is, so here's your speed control. These three wires here, we've got wiper, it's just a potentiometer, wiper, VCC and ground. So from 0 to whatever voltage that is, maybe 5 or 3 or 5 or something, we'll get a varied voltage on here on the wiper, and that'll tell it how far you've pulled the trigger. So that's going to control the PWM. Now if this was switched one particular direction and it pulsed both at the same time, we would get, what would we get? We would get, if this one turned on, we would get B plus through to that position negative. So if this was switched to the negative of the motor, which is at that position, then we get B plus through to the positive wire. That's always going through to the positive wire of the motor. If it was to switch that one on, we'd get positive through to the other side of the motor, and the motor wouldn't actually spin. So it's only during this one switching on that would create the motor to spin. So you'd get it one pulse negative, one pulse positive, and then when we switch the direction the other way, if that was switched out to here, we get two negatives on the motor, so it wouldn't matter. But when this one turns on, we get a positive and it would spin. So these have to be alternating. So the only way this can fail is if both of these are switching on at the same time. So we do need to perhaps look at that drive circuit and find out how that works and why that might not be the case. Let's look at the gate pins of both MOSFETs. Are they joined together? We'll just do a resistance test. They are not joined together. I wonder where they go through to. Probing around, I've found that the positive MOSFET goes to here. So this resistor, and the negative MOSFET goes to that resistor, so the gate there. So that is a 10 ohm resistor, and if we zoom down a little, or a lot even, this doesn't look the best on top here. It could just be the conformal coating, or maybe it's just completely burnt. Maybe. Let's go resistance mode, and this is looks like a 10 ohm resistor to the gate of the negative, and it is. And this looks like a 1K resistor to the gate of the positive one, and that's completely burnt out. Well, if that 1K is burnt, we're not getting the right signaling to the gate, whether it should be pulled down or not. Maybe it was floating, maybe the gate was floating as a result, which turned the MOSFET on when it shouldn't have, which fried it. Let me get another 1K resistor and a new MOSFET. That may have burnt the resistor when it shorted originally, perhaps, but we don't really know. The other resistors look fine. I'm trying to think if I saw this resistor looked a bit dodgy earlier. A little bit of goo. And see if we can stick this thing in all at once. How about that? Who needs hot air? Perfecto. Again, that's going to be a bit tricky because of the heatsink attached at the bottom. There we go, that should be enough to float. Now we're starting to go. There we go, drop some flux down. Come in with the part. Hold it down. Tidy up. That's all right. And clean. Okay, let's plug in the battery. We should get our light come on. There's our light. Now let's see if this will function without squealing. Here's hoping. Okay, here we go. Yes, no squealing. Right, pointed at the gear, you can see if it spins. Here we go. Woohoo! Look at that go! Haha! And instantaneous torque stop. Because usually when you get off the trigger, it like shorts the motor wires together through the trigger to make it stop really quick. You'll find most electric drills do that. Ha! Winner! Winner! What? Hey! Winner! Alright, let's get this thing back together. I've mostly assembled it. I put a couple of screws in just to hold it together for test so we don't have too much to disassemble if it's a complete failure. Let's pop in the battery. And it goes that way. We have our light. Cool. We should get our battery indicator here when I pull the trigger. And it works. Does it go the other way? Good. And we got the got the polarity right, of course, so that it's undoes in that direction. And it's an impact, so it will hammer at any items that are tight. So we could test that. So we'll put it in there so it can't rotate. There you go. Lots of power on that one. Well, I hope you all like to have a look at that Wurth brand of 3/8 cordless impact wrench. Model number is an ART 0700 233 019 or 018. I can't quite read that, but it's is what it is. I can't find any info online about these. It's almost like they never existed. If you like that, give it a thumbs up. And hang around for the next one. See you later.